Welcome back, and I've got a fun and very unusual experiment for you today. What we're going to look at is how we can measure the speed of sound by blowing up an old power station. So, you may know that during thunder and lightning storms, you see the lightning strike first and hear the thunder a little bit later, depending on how far away you are. The two basically happen together, but the light from the lightning strike comes to you almost instantly, and the sound from the thunder takes some time to get to you. And it's knowing about the fact that sound takes time to travel that we're going to use to see how fast sound travels through air. So a while back, an opportunity arose that was far too good to miss. A chance to measure the speed of sound by blowing up an old power station. But first a story and a little bit of history. So the Ironbridge B power station was coal-fired, and it sits in the Severn Valley, taking its cooling water from the River Severn, just above the iconic Ironbridge, next to the World Heritage Site. Now, when I was a little boy, 1980s, my father said they're having an open day at the power station, so let's go and have a look. Well, we arrived and they took us around the power station, and I remember going into the turbine hall, the whole building shaking, and it was absolutely deafeningly loud. They had to give us earplugs. Anyway, once we'd been around the insides of the power station, and I particularly enjoyed the control room area, they took us out to the cooling towers. And they weren't just big, they were absolutely massive. Well, it's funny how your life goes a full circle, because I ended up teaching in the area and taking school children around the power station myself. In fact, I even flew my plane over it a number of times because it's quite a good landmark. And I also showed the children the Jerry Foxall sculptures of pit ponies, which were made from bits of scrap metal left over from the original A power station. Anyway, the power station, if you remember, burnt coal, and that produces a lot of CO2, so its lifespan was limited. And when it was finally closed, they began the decommissioning. And it was an opportunity when they demolished the cooling towers for me to see if I could measure the speed of sound through air. So the date was set, the 6th of December 2019 at 11 a.m. They were going to press the button, the explosives would fire, and the cooling towers, all four of them, would collapse. Well, there's a little bit more to this, because Eric, my trusty horse, lives in a field just up from the power station. In fact, the National Grid power lines go right through his field. And I was mildly worried about what he and the other ponies might do as the explosives went off and the cooling towers collapsed. So, early in the morning, I packed my camera and a handful of carrots and went off to watch the cooling towers being demolished. So, I won't keep you waiting any longer. Here's the footage of the cooling towers being demolished. Now, I hope you noticed that when the cooling towers collapsed, it took a while for the sound to get to us in the field. And I'm sure you remember from your physics lessons that speed equals distance divided by time. So if we know from a map the distance to Eric's field, and with a stopwatch we know the time it took before the sound got to us from when the explosives were fired, we can work out the speed of the sound. So I got a map out with a suitable scale and measured the distance from the first cooling tower where the explosions first happened to Eric's field, and I got a distance of 1.3 kilometres. So that's 1,300 metres. So we've got the distance. All we now need is the time for the sound to get to us. So here's the video again with the stopwatch running next to it. And we're going to start the stopwatch just as we see the demolition explosives fire, and we're going to stop it just as the sound reaches us in Eric's field. Now that all happened rather quickly, so let's see it again in slow motion. So from this we can see it took 4 seconds for the sound to get to us. So if speed is distance divided by time, we put the numbers into the equation. So speed is 1,300 metres divided by 4 seconds, and that gives us a speed in air of 325 metres per second. Well, I must say I'm pretty pleased with that. I looked up the textbook value for the speed of sound in normal pressure and temperature air, in damp air, because it was a pretty damp day, and it gives 344 metres per second. We got 325, which is within 5% of the textbook value. So we got about 325 metres per second for the speed of sound in air. And it's worth pointing out one thing before we finish. I don't know how many of you, but I know I was told as a kid that you count the seconds off between thunder and lightning, and each second tells you how many miles away you are from the lightning strike. Well, you couldn't be more wrong. We've just shown that the speed of sound in air is about 330, 340 metres per second, which means that you count 1, 2, 3 seconds, and that would put it a kilometre away, and 5 seconds would put it a mile away. So thinking that 1 second is a mile away, that gap would mean you were very, very close to the lightning that's just struck, and perhaps you should think about getting into a safe place. So one more little anecdote before we finish. Many years ago, I was lucky enough to go to Florida to see the space shuttle launch. And it was a night launch. Now, obviously, it's a very, very powerful machine and you can't be very close. So we were sitting on the beach in the pitch dark, and then suddenly the sky literally lit up. It was like a fireball. And we saw this speck of bright light going up into the sky and going up and going up and going up and going up. And it was completely silent. And then the sound wave hit us. I'm told it can blow out windows in Orlando. But it was the huge time delay that made me realise that the shuttle had gone quite a long way up into the sky, but it had taken all of that time for the sound to get to us. Anyway, I do hope you enjoyed that rather special video and learnt a little bit more about the speed of sound and how you can measure it. Anyway, I'm off to see Eric with a handful of carrots, and I look forward to seeing you next time.